everything. You've heard of peak oil, the fact that we are now at the maximum production point, it seems, in terms of the availability of petroleum, and that from this point on, unless some unforeseen discovery happens, the availability of petroleum will be on the declining slope curve, the bell-shaped curve. We are at peak oil, and others argue, Dennis Meadows in particular, the author of The Limits to Growth, that we are at peak everything, in essence, because non-renewable resources now have been drawn out of the earth to their maximum extent, and we are just simply now, as a culture planet-wide, making every effort to discover new resources that still will be on the downslope of that bell-shaped curve. It is a globalized economy nowadays, as opposed to a localized economy. We'll talk some more about the implications of that in a minute. But the basic idea is that in an empty world, life is different. In an empty world, the relationship between the production of resources, of what we call biocapacity, and the consumption of resources is balanced. Ecosystems as a whole tend to operate in a balanced way when left to their own devices. The consumption, the disposal of waste materials, the recycling of those materials, the regeneration of natural capital, all happens in a closed loop. And that's a sustainable system by definition. Human beings have brought fossil fuels into the picture, and in so doing have brought a massive amount of carbon dioxide wastes into the natural environment, so much so that the natural environment doesn't know what to do with it. And so we have thrown the system out of balance. And although you can make other points about waste materials that are persistent and prevalent and therefore disrupt the system, it really is CO2, it is carbon dioxide that arises out of the use of fossil energies that is the biggest global problem these days. And I'm sure that's no news to this group. Without, Kirsten, you focused on that as a point of attention for everyone. So the question is then, what do we do about this? There are really only two solutions. What are they?
Acting or not acting?
Well, acting how?
Responsibly.
Yes, but what specifically would we do to address this emergence of CO2 into the natural environment? Yes, ma'am.
Either lower or get off the fossil fuel system completely. I think it's one, right?
Okay, good. The point is you want to reduce emissions, right?
Yeah.
Into the atmosphere, into the natural environment. What's the other thing that can be done in this system to rebalance the system? Yes.
You want to absorb excellent. Yeah,
Perfect. Exactly right. The idea is that we want to try to maximize or optimize the assimilation of those waste materials if we can, while at the same time reducing the emissions to the atmosphere. So those are really the two strategies that acting will lead to, that will have some effective long-term result. Well, the Global Footprint Network has looked at this question of peak everything, looked at this move from empty world to full world in the context of the resource base that the world provides to us. And so, this very simplistic model, this sort of cartoonish approach still is very informative. It shows that of the Earth as a whole, 51 billion hectares, multiply that times 2.5, and there you have the number of acres. 51 billion hectares, 4% of that is biologically productive ocean. Mostly that occurs along the coastal zones, along the continents. 18% of that 51 billion hectares is biologically productive land for agriculture, for forestry, for grazing, and so on. Together that represents about a quarter, 25% of the planet's surface. Not surprising numbers, but what's interesting is that leaders, global leaders, don't think very much about these types of planet-wide things. They don't take this planet-wide perspective very often. Our effort is to try to understand now how to manage these resources in optimum ways. And so we look at the productivity of the planet and we divide that out by the number of people on the planet, and we discover that there's an average for everybody in this room and every other human being on the planet of about 2.1 global hectares per person, about 5 acres apiece. You have 5 acres that you can deal with. It's productive ocean and productive land. You have 5 acres. everybody in the room does. How will you manage that? Will you grow crops on it? Will you grow trees? Will you harvest that in a sustainable way? How will other people manage that 2.1 acres? And what about all those other critters out there? What about the animals and plants themselves, who in assemblages, communities, also require some portion of the land base in order to do what they do? And we're not talking here about glamour species, we're talking about the essential fabric of the ecosystem, because as it turns out, biodiversity is the factory that actually produces the biocapacity that we consume. It's not just an unfortunate, or in many people's way of thinking, glamorous relationship between bugs and bunnies, animals and plants, but it is an essential network of interconnected species that develop for us the ecosystem services that you've spoken to here today, that process, that serve as the wires and switches for materials to move through the ecosystem so that ecosystems can function in a structural and holistic way. So really, we don't have a choice about how to manage for biodiversity. The question still becomes, though, how much do we set aside for that factor? Yes, Wayne.
I have a question that might be too literal. If it's the entire Earth, not all of the Earth is, if my 5 acres is ice, or the middle of the ocean, or desert, you know, is it just a theory, just a number idea, or could it be taken too literally to really be that divisible?
Your 5 acres occurs inside this 22% of biologically
Okay.
productive land and ocean. We're not talking about the rest of this.
Right. Okay.
See, because by definition, that doesn't produce biocapacity. It doesn't produce goods and services that you or I require to maintain our lives.
Thanks.
Okay? So we're talking about, and by the way, if you choose to go and live in Greenland, then perhaps the 5 acres becomes 20. Well, that's interesting. But there's certainly some considerations to be brought to bear there. All right, so we're back to the question of how much for biodiversity. E.O. Wilson, who you may know is a prominent thinker internationally on the question of biodiversity and the importance of species richness and ecosystem health, he suggests that 50% of that 2.1 hectares should be dedicated to preserving and protecting, to in fact restoring biodiversity as much as possible. So that means instead of the 2.1 hectares, we're down to about 1 hectare, about 2.5 acres apiece for housing, for food, for all of the ecosystem services that we require to maintain our lives. Well, that's on the supply side. Now let's look at the demand side. How much do we require in order to support ourselves? This is the question that the ecological footprint has brought to the table now for decision makers internationally. In order to organize our thinking about that, we focus on 5 different land types. You'll see 6 here, but I want to explain that in a minute. 5 different land types: built environment, such as San Francisco; fishing land or fishing area; we look at cropland or agricultural productivity; we look at grazing land; and when we look at forests for 2 purposes. First, to provide us with building materials or other types of important consumables, and then secondly, to sequester the CO2 that we emit to the atmosphere. Now, I argue to my colleagues at Global Footprint Network that a large part of the sequestration potential exists in the ocean and in restoring plankton productivity, which has been in decline for the past 30 years anyway. That's a nuance, but the point is that there is a component and a compartment of this footprinting process that's specifically dedicated to carbon sequestration, because it turns out that is a tremendous demand on the natural resource base. And if we ignore it, then we do so at our disservice, right? For lots of reasons. The system falls apart more quickly if we don't think about assimilating CO2 wastes. So the question then becomes, how much does each of us actually consume? The ecological footprint comes along to describe the area, biologically productive land and water, each of us requires to satisfy our needs. Basically, satisfy our needs for raw materials, for foodstuffs, and then of course to assimilate the wastes that we generate as a result.